Hi everyone, I know I'm not there, but I really need you to get this, so let's do a little bit of practice together, and then most of this will be on your own still, but I do want to go through just a few bits of the codominance, which is what we're seeing here, and the multiple alleles also here, and then sex linked a little further along in the packet. So in your notes, you learned about the four blood types, AB, which show codominance, right? They are equally shown, and O. Most of these will show a typical dominant and recessive trait. A and B are dominant to O, so O is recessive to everything, but A and B are codominant to each other. Although these are the blood types, we don't write them that way. We write them like this. Okay? So when we're talking about the possible genotypes here, we have for A blood, this right here is A, I, and then like a superscript A. So the two genotypes can be homozygous, right? You have two of the same, or heterozygous, two different ones, right? Homo and hetero, we know what those prefixes mean. Now, because A is dominant to O, right? This little I is representative of O blood. Because A is dominant, this will show A blood even though it has this will show A blood even though it has the O allele in it. Okay? Now for B blood, it's the same thing. It can be homozygous or heterozygous. There is only one genotype for AB blood because there's only one way to show both of these alleles, and that is one A allele and one B. And there's only one genotype for O blood, which is two little i's, because again, if anything else was paired with this I, it would show the other type of blood. So if there was an IA in front of it or an IB in front of it, it would show the other blood, because the little I for O is just recessive. Okay? So let's talk about this practice problem here. A man has type A blood and his wife has type B blood. They type their 4 children and find that each of the children have a different blood type. What are the genotypes of the parent, and how would you explain that all 4 blood types could be represented? Now, I know the answer to this, but there are some different ways that you could try and figure this out. You could do multiple Punnett squares to try and figure it out, but you need to find a way that both A blood and B blood can be represented with the ability to have this this little I genotype. The only way that you can do this is if you have 2 heterozygous parents. So the man who has type A blood is heterozygous for type A, and the woman who has type B blood is heterozygous for type B. When you do this, and in your explanation you can write this, when you have the cross of a Punnett square, this little I will match up with this little I, giving you the O blood. There's no other way to get O blood. If this was homozygous, we would end up with more A blood and no O blood. Now, for your explanation, you can do this in words, or you can do this in Punnett squares. I'm going to show you in Punnett squares, but that's kind of up to you, I guess. I would accept either. So, when you're doing a Punnett square, you set it up like this, and you can see down below here, I'll do this one too. You set up the genotypes on the top. It doesn't really matter which one you put on the top and which one you put on the side. It's typically I just put whichever one I've read first. So in this case, the man who had type A blood comes first. Because he came first here, I put him on the top. The wife who had type B blood came second here, put her on the side. No right reason, no rhyme or reason, no purpose. It doesn't change anything. Then when you fill this in, you're basically just taking this and crossing it until it matches in the box you want. So these two will come together in this box, which will give me AB blood. Now, you'll note that even though B is right here, I put it second. There's no such thing as BA blood. We don't call it that. Although it has the same alleles, we just don't call it that. So I'm not going to write it like that because that doesn't make sense. Then over here, we have B blood, A blood, and O blood. Okay? Pretty straightforward, right? All right. The last thing is just showing you how to set this up and how to fill this in. Ignore this. My son wanted to help. So a couple preparing for marriage have their blood typed along with the other blood tests. Both are AB. They ask what blood types their children may have. What would you tell them? So again, we're going to set it up based on their blood types. So AB we know is IA and then IB. And on the side, IA, IB. We know that already. Don't have to worry about it. So we know when we fill it in, we're going to have an A blood, AB, AB, and B. Okay, so again, you're just matching it up in the middle. Now for this part, you can do it in percentages or you can do it in numbers themselves. So the different genotypes that are found within this Punnett square are IA, right? I see that here. IAIB, I see that here. And IB. Now, I could write 1, 2, 1, right? I see this once, this twice, this once. Or I could write 25% A, 50% AB, 25% B. So you can do it in percentages or you can do it in numbers. I don't have a preference. Okay? So, moving on. I'm not going to do 7 with you because you guys have to do something on your own. I'm not going to do 8 or 9 with you, but I am going to show you at least how to set up a dihybrid cross. So dihybrid cross is done exactly like a monohybrid cross, which is the one I just did with you, except there's now 2 genes that we're looking at. So in this case, we're looking at the Rh gene and, of course, the blood gene still. So the Rh gene is what makes your blood positive or negative. A capital R is dominant over a lowercase r. Okay? So in this case, we're looking for the offspring that could be expected for an Rh positive AB woman. So you would write whatever you know in this blank. So we know that the woman's blood type is AB, so IA, IB, and we know that she is positive. Okay, great. But before I write that, oh look, there's something in parentheses. Whose father was Rh negative. We know we get half our genes from mom and half our genes from dad, which means that although she is showing the positive trait, she has inherited the negative trait as well, which puts her heterozygous. Okay? And then she marries a man with heterozygous A positive blood. So heterozygous A and heterozygous positive. So that means IA lowercase I and then capital R lowercase r. So far, so good? Okay. The problem with this is that I have 4 letters, I have 4 spaces, but I don't know how to split this up. You need to figure out how to have one of this section and one of this section represented in all of these. So if I have IA, IB, R, capital R, lowercase r, you do the first of the 2, and so my first space here is the IA and the capital R. Okay. Then you do the outside, so IA, lowercase r. Then you do the inside, IB, capital R. And then the last of the 2, which is IB and R. If you happen to be following along with what I was saying, you'll notice that I spelled out FOIL. First, outside, inside, last. That's the FOIL method. Okay, to do the same thing with here, I'm not going to do it like this, but I'm just going to explain it. You have the first, so IA capital R, right, first. The outside, IA lowercase r. The inside, lowercase I capital R, and then the last, lowercase I, lowercase r. Okay? Then you fill in the Punnett square exactly how you've been filling out Punnett squares. There's no special way to do a dihybrid cross. My only suggestion to you, and it's more of a you have to do it this way than suggestion, is to keep the genes together. So although you have IAR and IAR here, you're going to put your blood together and then your RH factor together. Okay, so this box would look like IA, capital R, capital R. Okay, you would not write it IAR. It makes it impossible to read later on. Trust me on this. Please do it the way I'm asking you to do it. Okay, so you'd continue on filling this out, ultimately getting here with IB, lowercase r, lowercase r, lowercase I, lowercase r, lowercase r. This whole thing would be filled out. You'd fill out the genotypes and phenotypes as we've done, but this is how you get your actual gametes, which is what these are called, along the side. Okay? All right, let's continue on. I'm not going to do any of these with you. These are just practice monohybrid crosses. These are pretty straightforward, and so I don't want to make this video any longer than it already is. So let's jump on over to sex-linked practice. Now, the key here is remembering that a female has XX chromosomes and the male has XY. All genes are located, all the genes that we're going to be looking at, let me clarify, all the genes that we're going to be looking at are on the X chromosome. So although the Y chromosome exists, it does not carry the genes. Therefore, when we write it down, it does not have a superscript letter next to it to show that it carries whatever it is we're looking at. Okay? So, our first example that we're looking at is color blindness. So, in order to be colorblind, a woman must carry the recessive allele for color blindness on both of the X chromosomes. A single copy of the recessive allele will cause color blindness in males because they only have one X. So they either have it or they don't. Okay? A male is either normal for vision or has color blindness. He cannot be a carrier. However, a woman can be a carrier, right? They can have one normal vision gene and one color blindness gene because they have two X's, okay? So I'm going to do 12 and 13 with you, and then we'll look at one more dihybrid, and then we will call it a day, okay? So the allele for color blindness is carried on the X chromosome and is recessive. We know that already, okay? A man whose father was colorblind has a colorblind daughter. Is this man, meaning this man, colorblind? How do you know? Okay, so this is got to break it down a little bit. So if the daughter is colorblind, that means that her genotype, so the daughter genotype must be X. I'm going to use A. I almost always use A for this. There's no purpose. It's just that the capital A looks different from a lowercase a, whereas a capital C looks the same as a lowercase c, so it's easier for me to differentiate when I use A's. So the daughter must be this. That's the only way she can be colorblind, is if she has two recessive colorblind alleles. Now, the fact that this man's father was colorblind actually means nothing. Because a man inherits the Y chromosome from their father. So although the father was colorblind, it means nothing to this particular question. However, if this man's daughter is colorblind, this daughter must have inherited the one X from mom and one X from dad. And if dad's genotype is XY and nothing goes on the Y, we know that the only X he's able to give is a lowercase a, meaning that he was colorblind. Now, where did he get his allele for colorblindness? I kind of already explained this, but remember, if we get one allele from mom and one allele from dad, this man's genotype, XY, the X had to come from mom and the Y had to come from dad because moms can't give a Y. So the Y has to come from dad, which only leaves this X coming from mom. So where did he get his allele for colorblindness? Mom. Must the fathers of all colorblind girls be colorblind? Yes. They have to be. Because the only way for a daughter to be colorblind is if they have two colorblind X's, and the only way for a dad to give a colorblind X is if he himself has it. So if he was anything other than colorblind, the daughter would not be colorblind. Must give a colorblind X. Okay? All right. Hopefully that makes sense. And we're going to move on to this part. This is similar, but we're going to kind of just fill all this out based on the pedigree of the family. So a man whose parents were normal with respect for color vision marries a woman of normal vision and similar pedigree, meaning that her parents also had normal vision. One of their daughters is colorblind. Okay, that should be like a ding, ding, ding. I know what this person's genotype is right off the bat. So give the genotype of this daughter, her parents, and the paternal grandparents. So the man's parents. So we know that the daughter is colorblind. So right off the bat, we know it's going to be that. Which means that one of these X's came from mom, and one of these X's came from dad. Since we know dad can only be X and Y, we've now figured out dad's genotype. Now, when we look at this, we see that he marries a woman of normal vision. So if the mom has normal vision, that means that the mom must have a normal allele. Now, we figured out mom, dad, and daughter. Now, we don't really care about them anymore because we're looking at the paternal grandparents. So, it says that whose parents were normal with respect for color vision. So we know that grandpa here had to be normal, and we know that he has a Y because it says grandfather. However, this dad got this colorblindness A from someone, right? Has to be mom because the X came from mom. But because she has normal vision, she is heterozygous. Okay? The heterozygous nature of this genotype kind of outweighs the fact that this colorblindness allele exists. So although the A is there, although the lowercase a is there, the capital A overshadows it. And again, does the father of a colorblind daughter have to be colorblind? Yes, they must be. Okay, now I'm not going to do much more with you, but I am going to just double check that I have everything that I want. Okay, I'm going to do one more Okay, sorry, my son was calling me. Okay, I'm going to do one more. I'm on number 15, so I'm not going to do this one. But again, hemophilia is recessive. So a woman who is a carrier is someone who doesn't show it but has it in at least one of their alleles. And a hemophiliac man, okay, so hemophilia is recessive. So just so we know the genotypes, this would be like this and like that, okay? Now again, I always use A. Old habits die hard. I don't know. You can use whatever letter you want. It really isn't a big deal. Okay, so I'm going to set this one up for you, and then that might be it for me. I'm going to call it a day because it's 7 o'clock at night, and I don't want to be doing this anymore. Okay, so brown eyes are dominant over blue eyes. This is not a sex-linked trait, which means that I don't need to write X and Y here. This is just going to be capital letters and lowercase letters, okay? So brown is dominant over blue. Cross a brown-eyed, colorblind male whose mother had blue eyes with a normal blue-eyed female whose father was colorblind. So I'm going to do my B's first because that's what they said. First, so a brown-eyed whose mother had blue eyes, which means that he inherited a little b from mom. So genotype of the male is capital B, lowercase b. And he's colorblind. So we know that he's going to be XY, and that colorblind is going to be a little a. Because it says that he's colorblind. And then a normal blue-eyed female. Well, the only way to show blue eyes is if you have two little b's, because if you had a big B, you'd have brown eyes. So we know little b, little b. Normal, meaning not normal vision, no, not colorblind, but whose father was colorblind. So we know that she is a carrier. Okay, so these are our genotypes. We're going to do the FOIL method like we did a couple problems ago. I'm going to put male on top strictly because it came first here. There's no reason why I have to. And you're going to take one of the B's and one of the sex genotype, put them together just like we did right first. So the first of the two of them is BXA. The outside is BY. The inside is little b x little a. And the last is little b y. Now remember, nothing goes on the y. So please don't write anything on the y. It's going to mess you up. And then for this one, I'm going to do the same thing. So the first of the two is BX. Capital A. Outside is lowercase b, x, lowercase a. Then the inside, little b, x, capital A, little b, x, lowercase a. So again, you just fill this out like normal. Keep your B's together. Keep your sex genotypes together. So this one would be B. I hate when you guys say it and I just said it like that. Capital B, lowercase b, x, capital A, x, lowercase a. So this is a brown-eyed, carrier, colorblind woman. Okay? So you're going to fill this out. Continue on just the way that we did the previous one. And then genotypes and phenotypes just like usual. Okay? Just going to double check there's nothing else I want to go over. I think now that you have this, you should be able to do this without me. A lot of this is just like critical thinking skills and like following the way that these chromosomes are inherited. So now that you have it, I think I feel good about it. I'm going to leave this one completely up to you. Okay, and then that's it. So good luck. If you have questions, keep the questions for the next time I see you, which will be Friday. And Happy Punnett squaring.